Analysis Services has several different tools to help you monitor and tune the performance of your servers. The choice of tool depends on the type of monitoring or tuning to be done and the particular events to be monitored. In this Azure Everyday series, we will take and explore several different monitoring tools that range from monitoring the health of Azure Analysis Services to profiling data for SQL Server Analysis Services, Tabular, and Multidimensional. These events enable you to monitor your server and database activity. The monitoring and uncovering of information that is specific to Azure Analysis Services Tabular, and Multidimensional instances itself, and associated techniques such as profiler traces, X events, DMV queries, etc. are extensive. We will look at a few of the options available to us. Analysis Services has several different tools to help you monitor and tune the performance of your servers. The choice of tool depends on the type of monitoring or tuning to be done and the particular events to be monitored. There are about 7 to 8 different monitoring tools options available. Azure Metrics Explorer is a free tool in the Azure portal to help you monitor the performance and health of your Azure Analysis Service servers. Azure Diagnostics uses Azure Diagnostic Logs to monitor and log Azure Analysis Services and your server performance. You can send logs to Azure Storage, stream them to Azure Event Hubs, and export them to Azure Monitor Logs. SQL Server Profiler tracks engine process events. It also captures data about those events, enabling you to monitor server and database activity. Extended Events are a lightweight tracing and performance monitoring system that uses very few system resources, making it an ideal tool for diagnosing problems on both production and test servers. Trace events follow the activity of an instance by capturing and then analyzing the trace events generated by the instance. Trace events are grouped so that you can more easily find related trace events. Dynamic management views are queries that return information about model objects, server operations, and server health. The query, based on SQL, is an interface to schema row sets. Performance counters use performance monitoring. You can monitor the performance of Analysis Services instance by using performance counters. Also, with log operations is associated with Analysis Services instance will log server notifications, errors, and warnings to the msmd srv.log file, one for each instance that you install. These last two monitoring options are on-prem options only and multidimensional only. So to understand how to conduct performance monitoring, it's also important to understand how the different flavors of Analysis Services, multidimensional and tabular, process queries or how they answer queries. In multidimensional, an MDX query comes in and an XML listener, which accepts the request, parses the request, and passes it along to the query processor for query execution. The query processor, upon receiving a validated and parsed query from the query parser, the query processor prepares an execution plan which dictates how the requested results will be provided from the queue data and the calculations used. The query processor caches the calculation results in the formula engine cache. The storage engine responds to the subqueue data, a subset or logical unit of data for querying, caching, and data retrieval. Request generated by the query processor. It first checks if the requested subqueue data is already available in the storage engine cache. If yes, then it serves it from there. If not, it checks if the aggregation is already available for the request. If yes, then it takes it from the aggregation store and caches it to the storage engine cache. It also sends it to the query processor for serving the request. If not, then it grabs the detailed data, calculates the required aggregations, and caches it to the storage engine, and then sends it to the query processor for serving the request. While troubleshooting, you need to understand which component is taking more time and needs to be optimized, such as the query processing engine or the storage engine. To determine this, you can use SQL Profiler to perform an OLAP trace and capture certain events which will tell you the time taken by these components. To summarize, the formula engine works out what data is needed for each query and requests it from the storage engine. The storage engine handles retrieval of raw data from disk and any inner aggregations that are required. When aggregations are used, aggregations are only useful when the storage engine has to fetch the data from disk. Aggregations will not be used if the data is in the storage engine cache. Aggregations may not be useful if the cause of the query performance problems lies in the formula engine. Tabular models can be queried by using both MDX and DAX queries. The diagram explains the underlying query processing architecture of analysis services when running in tabular mode. DAX queries can reference DAX calculations. These DAX calculations can reside in the model, in the session, or in the defined clause of the DAX query. Power View reports generate DAX queries to gather the data they visualize. MDX queries, on the other end, can reference MDX calculations either in the session scope or in the with clause of the MDX query. MDX calculations can also reference DAX calculations, but the reverse is not true. MDX queries can directly refer to DAX calculations embedded in the model, and an MDX statement can also define new DAX calculations on the session scope or in the with clause of the MDX query. MDX queries against tabular models are not translated into DAX queries. MDX queries are resolved natively by the MDX formula engine, which can call into the DAX formula engine to resolve the DAX measures. The MDX formula engine can also call directly into the VertiPack engine in cases such as querying dimensions. Excel generates MDX queries to support pivot tables connected to analysis services. DAX calculations in the formula engine can request data from the VertiPack storage engine as needed. The formula engine allows very rich, expressive calculations. It is single-threaded per query. The storage engine is designed to very efficiently scan compressed data in memory. During a scan, the entire column, all partitions, and all segments are scanned, even in the presence of filters. Given the columnar storage of VertiPack, the scan is very fast because the data is in memory, no I/O is incurred. Unlike the formula engine, a single storage engine query can be answered using multiple threads. One thread is used per segment per column. Some very simple operations such as filters, sums, multiplication, and division can also be pushed down into the storage engine, allowing queries that use these calculations to run multi-threaded. The formula engine commonly runs several VertiPack storage engine scans, materializes the query results in memory, joins the results together, and applies further calculations. However, if the formula engine determines that a particular calculation can be run more efficiently by doing the calculation as part of the scan, and if the calculation is too complex for the storage engine to compute on its own, for example, an if function or the last date function, the VertiPack storage engine can send a callback to the formula engine. Though the formula engine is single-threaded, it can be called in parallel from multiple threads servicing a single VertiPack scan. In this session, we took a look at the several different monitoring options for Azure Analysis Services and Analysis Services Tabular and Multidimensional. We also took a look at the different underlying in-memory engine for VertiPack Tabular and also the underlying internal engine for multidimensional. In subsequent sessions, we will be looking at how to use certain tools to provide monitoring of your analysis services solutions. Thank you for reviewing this Azure Everyday session. Have a great day.